Hello, it's your NOLA Mathman coming on the scene. Unlike Superman, I may not be able to leap tall buildings in a single bound. I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
Let's get started here as we attempt to learn some new concepts in Algebra 2 and slay these math demons like Superman slays the villains in the story. So let's get started. We're doing section 4.1, graphing quadratic functions, and let's begin. So our first problem here is f of x equals negative 2x squared. Our goal is A, find the y-intercept, the equation of axis of symmetry, and the x-coordinate of vertex. B, make a table of values that includes a vertex. And C, use that information to graph the function. So we write down our function, f of x equals negative 2x squared. Next, we write the general form of the quadratic function, ax squared plus bx plus c, because in order to answer these questions, we must pull out a, b, and c. So as you can see, a is negative 2 in the problem, b is 0, and c is 0. So at this point, we know that the y-intercept is equal to c. And so in this problem, the y-intercept is going to equal what? Well, it equals 0, as you can see, because we pulled out c equals 0. So next, we want to find the equation of the axis of symmetry. The equation for that is x is equal to negative 1 times b over 2a. And so that's going to pop up. It is a vertical line that creates the line of symmetry. And so as you can see, the equation pops up here, negative 1 times b over 2a. Since b is 0, we will substitute 0 for b, and we will substitute negative 2 for a. And so we will have negative 1 times 0 in the in the numerator, and 2 times negative 2 in the denominator. So doing order of operations, 2 times negative 2 is negative 4, 0 divided by negative 4 is 0, and so x is equal, because negative 1 times 0 is 0, anything times 0 is 0. The axis of symmetry will be x equals 0. And so at that point, that allows us to create a vertical line at the, basically x equals 0 is a y-axis, so we will create our axis of symmetry there. At this point, the problem asks to find the x-coordinate of the vertex. The good news is the axis of symmetry and the x-coordinate of the vertex are exactly the same. So the x-coordinate of the vertex will be equal to 0 also, like the axis of symmetry. So at this point, we will go to the B part, which basically says, make a table of values that includes a vertex. So the vertex value for x is 0, as we just calculated. So we will put that in the middle of the table, and from there we will pick 2 points to the left of 0, which are negative 1 and negative 2, and then we will pick 2 integers directly to the right of 0, which are 1 and 2. And so we will substitute those x values into our equation, negative 2x squared, to figure out what y is, because f of x is the same thing as y. And so right now what I'm going to do, since I already calculated the y-intercept, I'm going to put that on the side so we can use it later to graph. We're also going to put down the axis of symmetry. Once we erase this work we've already done, we're going to write the equation for the axis of symmetry, which we will use later to graph our function once we get our ordered pairs from the table. So right now, that's what we're going to do. And you want to get all this information together in a concise fashion, so that once you have your table of values, you're able to graph very accurately with no problems. So right now, we're going to erase and start filling our table. So that'll take a sec here. So the first value, what's the first value we need to find y for? Well, it's for x value, the vertex, which is 0. So we set x equals 0. We substitute 0 for x in the equation, negative 2x squared. 0 becomes x. 0 squared is 0, and negative 2 times 0 will give me a y value of 0. So our first ordered pair would be 0, 0, which happens to be our vertex over here. So next, we will find the y value for x equals 1. Or negative 1, because it's symmetric, it doesn't matter. So we either pick, we don't have to find the y value for all 5 values of x, we just need to find it for 3, because of the fact that since it's symmetric, the y value 1 unit to the left has to be equal to the same y value 1 unit to the right, because parabolas are symmetric. So so we don't have to find the y values for negative 1 and 1. We can just pick one of those values and calculate the y value, which we're about to do in a sec here. So while we're doing that, we want to make sure we have all our stuff. Here we go. So the value of 1 is the next value we will pick for x. We write our equation, negative 2x squared. Where x is, we will substitute 1. And now we use order of operation. 1 squared is equal to 1. And negative 2 times 1 will be negative 2. So now, when x is 1, y equals negative 2. So our next order pair will be 1, negative 2. And since we know y is negative 2 and x is 1, we know 1 unit to the left, negative 1, y has to have the same value of negative 2. And so we write that coordinate down in our table, negative 1, negative 2. So at this point, we will find the y value when x is either negative 2 or 2. It doesn't matter which one because they have the same y value. So we're going to pick 2. We like to deal with positive numbers. It makes it easier. And so we write our equation again, negative 2x squared. We substitute 2 for x. Using order of operation, we square 2. 2 squared is 4. So we will have negative 2 times 4, and negative 2 times 4 is negative 8. And so when x is 2, y is negative 8, which means when x is negative 2, y is also going to equal to negative 8, which will pop up in a sec. There we go. And then for when x is 2, we just calculated y to be negative 8. So now we have our 5 values, and we can now graph our quadratic function. So that's what we're about to do, which is the final part of our problem here. So we're going to erase this, and well, we don't have to erase it. We can just start plotting. So the first thing we do is plot our vertex, which is 0, 0, which is the origin. You see that there. And now we graph negative 1, negative 2. We graph 1, negative 2. As you can see, that's on the graph there. And we're going to now graph, well, now we produce the axis of symmetry. We could have did that first, but it doesn't matter because that lets you know that the values are symmetric on the left and the right side of the axis of symmetry. As you can see here, we label our axis of symmetry right there, as I do here. And so now we graph the final 2 points, 2, negative 8, which is 2 units to the right and 8 down. And then we go 2 units to the left and 8 down. And now we have our parabola. So now we connect those points together in a curve-like fashion. And we now have our graph. So we have graphed f of x equals negative 2x squared. We're done. So look. Very simple, there we go. And the more you do this, the easier the concept will become. So we will erase this problem and go to our next problem. So that went well. So we're waiting to see which problem we're gonna do. Sometimes you can go next to 2. Sometimes we'll skip and go to another problem that's a little more challenging, so to speak. So we skip 2 and go to number 3. So now we have here f of x equals x squared minus 6x plus 8. Our objectives are the same as in the first problem. We're going to find a y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. We'll make a table of values that includes a vertex in the middle, and we will use this information in the table to graph our points and get our graph. So first thing we do is we write our equation. F of x equals x squared minus 6x plus 8. Just like we did in the first problem, we want to write the general form of a quadratic, which is ax squared plus bx plus c, so we can pull out the a, b, and c values. In this problem, a is equal to 1, b is equal to -6, and c is equal to 8. So by knowing that c is 8, we know that our y-intercept is equal to c. And since c is equal to 8, we know that the graph crosses the y-axis at 8. And so y-intercept is 8. We write that down. So now we find the equation for the axis of symmetry. We know the equation again is -1 times b over 2a. So since b is -6, we will plug that into the numerator. Since a is 1, we will multiply 2 times 1 in the denominator. And we will use order of operation rules to solve for x. So using the order of operation rules, 2 times 1 is 2. So we'll have -6 over 2. Then we simplify -6 divided by 2. That will be -3. And then finally, our final calculation is -1 times -3. Two negative numbers give you a positive sign for the product, and so x is equal to 3. So our axis of symmetry for this problem is a vertical line at 3, at positive 3. Now we're able to, next thing we have to do is find the x-coordinate of the vertex. What I'm doing here is summarizing what we got for the axis of symmetry, which is x equals 3, as you can see on the screen. And now we're going to find the x of the vertex, but since the axis of symmetry and the x-coordinate of the vertex are the same, we don't have to do the calculation again. We just put x is equal to 3. So now we're able to start constructing our table. We will put 3 in the middle of the table, and we will pick 2 x values to the left of 3, which will be 1 and 2. And we'll pick the next 2 values to the right of 3 when they increase, and that will be 4 and 5. And so that should appear in the table any second now. So we'll wait to see that. But the first thing we do is we put our x-coordinate of the vertex there, like we just did. And now again, we will pick the 2 values to the left, which are 1 and 2. We'll pick 2 values to the right of 3, which are 4 and 5. And that'll allow us to construct a symmetric parabola, which we know all quadratic functions follow that form. So now that we have picked our x values, we will substitute into the equation f of x equals x squared minus 6x plus 8 to find our y value, since we know f of x is equal to y. It's the same thing, which I will probably write here in the table on the board in a few seconds. So what I'm doing here is we are again pulling out the y-intercept, writing that down, and storing that away from when we're ready to graph. And we're going to write down the equation for the axis of symmetry, and that allows us to erase this work we have and start to calculate our y values. So what's the first y value we're going to do? Well, we will set x equal to 3, since that's the x-coordinate of the vertex. So where x is, we have 2 x's in this equation. We substitute the value of 3. So instead of saying x squared minus 6x plus 8, we'll have 3 squared minus 6 times 3 plus 8. Using order of operation rules, 3 squared is 9, -6 times 3 is -8. Now we go from left to right. Instead of going left to right, we combine the 2 positive numbers. 9 plus 8 is 17. We bring down to -18, and 17 minus 18 is -1. So at this point, we write that value in the table. So when x is 3, y is -1, and so our vertex point will be 3, -1, as you can see here in the table. So next thing we're going to do is, again, like we did the last problem, since the y values for x equals 2 and 4 are the same, since they're 1 unit to the left and right of the x-coordinate and the vertex, we can pick either x equals 2 or x equals 4 and solve for y. So we're going to see which one we're going to pick in a sec. Typically, I try to pick the higher value. So this time, I graph the axis of symmetry since everything is symmetric. I plot the y-intercept, which is 8 units up on the y-axis, and since that's 3 units to the left of the axis of symmetry, I know there has to be a corresponding point 3 units to the right, which we plot a point which is at 6, 8, the coordinate 6, 8, and so you can see that. So that allows us to get 2 extra points outside of the table of points that we're already constructing. So at this point, we will set x equal to 4, and for each value of x, we will substitute the value of 4. So instead of saying x squared, we'll put 4 squared. Instead of saying -6 times x, we will say -6 times 4, and then we will calculate using the order of operation rules. 4 squared is 16, -6 times 4 is -24. We combine the like terms. 16 plus 8 is 24. We bring down to -24, and so our y value will be equal to 0. So now in our table, we can put 4, 0, and since 2 has the same value of y, we know we will have 2, 0 there. And so we now have 3 of our 5 points that we need to graph. So as you can see, we're graphing the 2 points, 2, 0, and 4, 0. They now appear on the graph. And we fill it out in the table, and we put it on the graph using both. So we have a good way of checking to make sure the table is right by looking at the graph, and we can make sure the graph is right by comparing it to the table. So it's a good way of allowing you to self-check, so to speak. At this point, we will set x equal to either 1 or 5, which should appear in a second on the whiteboard. Let's see here. So while we're doing that, we really don't, since we already got 2 points from the y-intercept, we don't necessarily have to get the other 2 points because we have 5 points. But we will set x equal to 5 so we can get the more points you get, the more thorough your graph will be. So we will now pick x equals 5. We will substitute into the equation x squared minus 6x plus 8. Where the values of x is, we will substitute 5. And so we will have 5 squared minus 6 times 5 plus 8. 5 squared is equal to 25. -6 times 5 is -30. We will combine the like terms, the 2 positive numbers. 25 plus 8 is 33. We will now subtract 30 from that, and we will get a value of y, which is equal to 3. So now we have our final points in our table, and so we write those down. 1, 3, because we know that 1 has to have the same value as y as 5 does, as we said, because it's symmetrical. So now we will plot those last 2 points on our little board as it is appearing now. And we will connect those points and create our parabola, which is happening right now. Here we go. Looks very nice. Very good. As you can see, the parabola is symmetric around the axis of symmetry. As you can see with curves, it could be a little weird there. So it doesn't have to be perfect. I mean, it's not like drawing a straight line. So sometimes you'll mess up in your little curves, as I did in the graph that you see above. So now we erase and move on to our next problem. now done 2 quadratic functions there and graphed them. I hope you're feeling more comfortable with the process of graphing. As we get through each problem, we will get more and more comfortable with the process of graphing. So now we're going to go to a different group of problems with different directions. So now this problem states, determine whether each function has a maximum or a minimum value and find that value. Then state the domain in range of the function. So we haven't done this yet, so we'll do something a little different. So we're doing, I think, it said problems 4 through 9. There we go, they pop up there. And so in each problem, we have different directions. We're not graphing them per se. We're determining whether each function has a maximum or minimum value. And once we figure that out, we will find that value, and then we're going to state the domain and range. So we'll start with problem number 4. 6x squared. Again, we write the general form of a quadratic function like we did in the problem where we're graphing. Ax squared plus bx plus c. Because in order to do these things, we need a, b, and c. And so we will pull out the value of a. That's what determines whether it will be a maximum or minimum, because that determines if the parabola opens up or goes down. So since a is equal to 6, we can determine that it opens up because it's greater than 0. So before we do that, we pull out a, b, and c. Since a is greater than 0, as I said before, this allows us to determine that it's an upward parabola and it opens up. And if it opens up, then it means the bottom, the vertex will be what we call the minimum value. Since it opens up, it's the lowest value. So we know at this point that we will have a minimum value and that the graph goes up. And since the graph goes up, we know that it will determine, create a minimum value. So at this point, we want to find that minimum value. So how do you do that in class? What will we do? What's the process of finding the actual minimum value? We know we have a minimum value because it opens up. And how do you go about determining the minimum value? Well, you will use you need the vertex value. So we had in the last problem a formula or equation for the x-coordinate vertex, which is -1 times b over 2a. So since b is 0, we substitute 0 for b, we substitute 6 for a, and we calculate that formula to get the value of x. 0 over anything is 0, so 0 over 12 is 0. -1 times 0 is 0, and so the x-coordinate of the vertex is equal to 0. So in order to get the minimum value, all we need is the f of 0, which is our vertex. So we substitute 0 into our function 6x squared. 0 squared is 0, and 6 times 0 is 0. So the minimum value for number 4 for the function f of x equals 6x squared is equal to 0. So now we have found that value. So the next thing we have to do is we need to state the domain and range. Now, because it is a parabola and it goes on indefinitely to the left and right, the domain will always be all real numbers for a parabola. The range has a limit because you have a vertex point, and since it opens up, we know that the range has to be greater than, since it's increasing. So f of x will be greater than whatever the function, the vertex value for y is. And since the range is equal to 0, the minimum value, our range will be f of x is greater than or equal to 0. It's easier to understand this when you see the graph like we had earlier when we were graphing. So, but take my word for it, that's what it is. The range is typically going to be the y value greater than whatever the minimum value is. So since the minimum value is 0, we put f of x is greater than or equal to 0. So now we're going to do number 6. This problem reads f of x is equal to x squared plus 2x. So again, we're going to do just like we did in the last problem. We will write the general formula of a quadratic function, which is ax squared plus bx plus c. We will pull out a, b, and c. A is equal to 1, b is equal to 2, c is equal to 0 since there's no value added to the 2x. Since the a is positive 1, we know it's greater than 0. So we know this is a parabola that opens up. Since it's a parabola that opens up, what kind of value does that produce? As you can see on the screen, it produces a minimum value because the vertex is the lowest point when the parabola opens up. So now we have to find the value, the minimum value. We have to find that actual value. And so what we will do, like we did in the last problem, we will calculate the x coordinate of the vertex, which is negative 1 times b over 2a. Since b is equal to 2, we will substitute 2 for b. Where a is, we will substitute 1. So now we have negative 1 times 2 times the quantity of 2 times 1 in the denominator. Unit order of operation, 2 times 1 will be 2. 2 divided by 2 is 1. And so now final calculation is negative 1 times 1, which is negative 1. So the minimum value is equal to the f of negative 1, or the y value when x is negative 1. And so we substitute negative 1 into our function, which is above, as you can see, x squared plus 2x. Where the x's are, we substitute negative 1. Unit order of operation, negative 1 squared is 1. 2 times negative 1 is negative 2. 1 minus 2 is negative 1. Therefore, the minimum value in this problem is equal to negative 1. So now we will find the domain and range. As we did in the last problem, it is typically with parabolas, the domain will always be all real numbers. And so now the range, since our minimum value is equal to negative 1, the f of x will be equal, greater than, since it's going up, the f of x should be greater than or equal to negative 1. Which should pop up in a second for our range. Here we go. And so that is my range. F of x is greater than or equal to negative 1, which you can also state is y, because f of x is equal to y, and range is the set of y values. So you can put y greater than or equal to negative 1 also. So now we're done with that problem. We've answered all the questions for number 6 that we need to. And now we'll go on to another problem. So let's see which one we'll do now. Hope you're getting the process better. The more you do these, the easier it comes. So now we're going to do number 7. So this time we have a different type problem because your a term, as you can see, is negative 2. We've been typically doing problems where a is a positive number. So let's see if that changes what we do. So we write the general form of the quadratic, ax squared plus bx plus c. We pull out a, b, and c. A is equal to negative 2. B is equal to 4. C is equal to negative 3. And so since a now is not greater than 0, a is negative, we know it's less than 0. Instead of opening up, this parabola will open down. And so instead of having a minimum point, since it opens down, the vertex is the highest point in this type of parabola. And so it becomes your maximum value. So we're looking for a maximum value because a is equal to negative, which means the parabola opens down. But just like we did before, in order to find a maximum or minimum value, we need the x coordinate of the vertex. So we use that same equation, negative 1 times b over 2a. Where b is, we substitute 4. Where a is, we substitute negative 2. Follow order of operation rules. 2 times negative 2 is negative 4, so we have 4 over negative 4. 4 divided by -4 is -1, so our last calculation will be -1 times -1, so x is equal to 1. So x coordinate is 1, so in order to find the maximum value, we need to find our f when x is equal to 1, or f of 1. And so we will substitute that into the equation. Where the x values are, we will substitute 1 to replace it, and we will solve it mathematically. So the problem will read -2 times 1 squared plus 4 times 1 minus 3. Using order of operation rules, 1 squared is equal to 1. We bring down 4 times 1. Oh, I'm sorry, we go ahead and solve that, which is 4. -2 times 1 is -2. -2 plus 4 minus 3 is our next thing, doing order of operations. We can go left to right, or we can combine the two negative numbers. Let's see how we choose to solve it here. Oh, we put the two negative numbers, -2 and -3 is -5. We bring down +4, and -5 plus 4 will give us a value of -1. So in this problem, our maximum value is equal to -1, as you can see there on the screen. So at this point, we need to find the domain and range. And at this point, everybody should know, what do you think, before it pops up on the screen, what do you think our domain is going to be? It's going to be the same thing it's been in all the problems so far. Domain is going to be all real numbers. So we should be able to see that pop up in a second here. I'll just let you know that. So, domain, all real numbers, like it is normally in every problem. Now, our range is different than before because we have a maximum value. Instead of saying f of x is greater, we'll say f of x is less than or equal to -1, which was our maximum value. And so that completes our problem. So we did a problem that's a little bit different. Didn't change a lot, as you can see. The only difference is when a is negative, you have a maximum value, and the range is less than or equal as opposed to greater than or equal when it's positive. So let's see what happens next. What we'll do now. It's our next problem here. I'm waiting. So while we're waiting, I hope everyone's understanding the process. Hopefully this is allowing you to understand it better. Oh, we're going to go to number 9, do one more problem. We find the max or min value. So we write the equation. F of x equals 2x squared plus 4x plus 1. Like we've done in every other problem, we want to follow the same routine over and over. We write the general form, ax squared plus bx plus c. We pull out a, b, and c. A is equal to 2, b is equal to 4, c is equal to 1. We know since a is a positive number that it opens up, which means we have to create a minimum value. So we know we'll have a minimum, I meant minimum point, but we meant minimum value because you have a vertex point that's a minimum. So at this point, we will find the x coordinate of vertex like we've been doing. X is equal to -1 times b over 2a. B is equal to 4, so we substitute that in. A is equal to 1, so we substitute, A is equal to 2, so we substitute 2 for A. And so 2 times 2 is 4, so we have 4 divided by 4, which is 1. Our final calculation to solve x is -1 times 1, so x is a value of -1. So now, in order to find our minimum value, we will find f of -1. So we substitute -1 into our function. 2x squared plus 4x plus 1. And where x is, we substitute -1. So we have 2 times -1 squared plus 4 times -1 plus 2. Using order of operation, -1 squared is 1. Positive 4 times -1 is -4. 2 times 1 is 2. We now have 2 minus 4 plus 1, we add the positive numbers. 2 plus 1 is 3. 3 minus 4 gives us a minimum value of negative 1. So we're done with that. Our minimum value again is negative 1. Now we're able to determine the domain of range. And again, let me ask again, what is our domain gonna be? You know, I mean, we've done it like over and over at this point. Let's guess. I would assume the domain should be all real numbers. Let's see what happens. There we go. Looks like it's being written all real numbers again. The E looks kind of jacked up there, but we gotta work on the handwriting. And for the range, since our minimum value is negative 1, and we know it opens up, we know it's f of x greater than or equal to negative 1, which should pop up any second. There we go. And so now we have completed number 9, and we are done with these set of problems. And hopefully you are getting the same values, and the more of these you do, the more comfortable you will get doing these problems. So let's see where we go next. Erase it. I hope everybody's learning and understanding these concepts better. So we got some more of these problems left. 10 through 15, where we have the same directions. Determine whether each function has a maximum or minimum value and find that value. You can never do enough of these problems. The more you do, the more confidence you get in doing them. So you don't want to relegate yourself to 1 or 2. You want to do as many as possible, because math is a subject of practice. It's like being a pianist, playing the piano. You have to practice, or being an athlete, you got to constantly practice and hone your skills. Math is the same way. You have to constantly do problems, even if it's the same directions, because each of the problems have, their own differences in the problem. So we're going to do a few more of these, and then we'll be done with this section on graphing quadratic functions. So let's see what we do next. We're waiting to see which problem do you think we're gonna do. We've done every type of problem. Okay, let's go to number 12. That'll be our next problem. So we have here f of x equals negative x squared plus 6x minus 15. So what do you think we're gonna do first? You know what we're going to do first. We're going to write the general formula for quadratic function, ax squared plus bx plus c, which I would advise you to memorize. It's very important. That's one of the most important formulas in quadratics. So we will pull out the values of a, b, and c. A is negative 1, b is equal to 6, c is equal to negative 15. Since we know a is a negative, it's less than 0, we know that it will open down. And so our vertex point will be our highest point. So we know we will find a maximum value in this problem. And so we have a maximum point. So now we have to find the x-coordinate of that vertex that represents that maximum point. We use the same equation we've been using, negative 1 times b over 2a. b is equal to 6, so we substitute 6 for b, substitutes negative 1 for a. We have 2 times negative 1 in the denominator, which is negative 2. Now we simplify 6 divided by negative 2, which is negative 3. And our final calculation to find x will be negative 1 times negative 3, which is positive 3. So at this point, in order to get the maximum value, we substitute 3 into our function. Negative x squared plus 6x minus 15. So when you substitute 3 in, according to order of operation, you must remember, because people make this error a lot, you will square 3, positive 3 first, before you multiply the negative 1, as you can see, and that's why you get a value of negative 9. 6 times 3 is 18. At this point, we combine the like terms, negative 9 and negative 15 is equal to negative 24. We bring down a positive 8. You add unlike signs, the answer is going to be negative 6 because 24 minus 18 is 6. And since the highest number is negative, the value is negative. And so the maximum value in this problem will be equal to negative 6. At this point, we will get the domain and range. And at this point, it should be old hat, second nature. Everyone should know at this point what your domain is going to be. So let's say it all together. All real numbers. Doesn't change, my friends. Every time you do a parabola, the domain is going to be all real numbers for the most part. As you can see, it's popping up there on the screen. And the range, as we have done repeatedly, will be f of x. Since it's a maximum value, we know it's less than or equal to negative 6 because that's our maximum value. And since it's going down, we put less than or equal to negative 6, as you can see there. So by now, I think everyone should get the little pattern and routine of how these go. But you want to continually practice them to get more confidence in doing it, so that it'll become eventually second nature. So we are done with number 12. Is there any others we're going to do here? Let's check it out. In the video, I want to do as many as possible so that you can get, check your solutions and make sure you're doing them right. So now we're going to do number 13, which reads f of x is equal to 2x squared minus 11. This time we write the general formula ax squared plus bx plus c. Now, since there is no x term, we know b is equal to 0. A is equal to 2, c is equal to negative 11. Since a is 2, that's greater than 0, we know it opens up, and we know our vertex is a minimum point. So in order to get our minimum value, we get again the x-coordinate of the vertex, negative b over 2a. We substitute 0 for b. We substitute 2 for a. So we have 0 divided by 2 times 2. 2 times 2 is 4, so we have 0 over 4. 0 divided by 4 is divided by any number is 0. And negative 1 times 0 will get you 0 because anything times 0 is 0. So the x-coordinate of the vertex is 0. To get our minimum point, we will take f of 0. So where x is in the problem, 2x squared minus 11, we'll substitute 0 and solve it. 0 squared is 0. 2 times 0 is going to give me 0. We subtract 11 from 0, and the minimum value will be equal to negative 11, as it will appear on the screen here in a second. So at this point, we get again, what do we need to do now? What we need to do, as it says in the directions, we will state the domain and range. And as we know, by doing problems over and over, we know that the domain has to be what at this point? Yeah, I'm waiting. Okay, there we go. Everybody said it by now. All real numbers, because there's no restriction on x. That's what it means. The parabola goes on forever in the left direction, which is the negative. It goes on forever in the right direction, which is positive. So that's basically what that means. So the range is, since our minimum value is negative 11, minimum means it's greater than or equal to negative 11. F of x greater than or equal to negative 11. So, are we getting that? I'm sure by now we're getting to be experts at this. And so the more you do, the less fear you should have over this, and the more confidence you should be attaining as you do each and every problem you do. The more confidence should be swelling up in your bean. Okay, last problem here. F of x, negative 2x squared plus 8x plus 7. So again, what do you think we're going to do first? Well, you know we're going to do first. We're going to write the general form of the quadratic. Ax squared plus bx plus c. As we normally do, we will pull out a, b, and c. A is negative 2, b is 8, c is 7. Since we know a is less than 0, we know that we will have a maximum point because it opens down. The parabola opens down, so it creates a maximum point at the vertex, as we state here on our little graph board, on our little work board, I call it, so to speak. So in order to get that maximum value, we need the x coordinate of the vertex. As we know, that's negative 1 times b over 2a. You write the general formula. You substitute 8 for b, substitute negative 2 for a. Using the order of operation, 2 times negative 2 is negative 4, so we have 8 over negative 4. 8 divided by negative 4 is negative 2. The final calculation is negative 1 times negative 2, which is positive 2. And so now we know our x-coordinate of the vertex is 2. In order to find the maximum value, we substitute 2 into our function. Negative 2x squared plus 8x plus 2. Where the x's are, we substitute 2. We use order of operation. 2 squared is equal to 4. So we'll have negative 2 times 4. 8 times 2 is 16. Bring down to 7. Negative 2 times 4 is negative 8. We combine the two positive numbers and we will have 23. It should pop up in a sec. And negative 8 plus 23, it didn't pop up, we just did it in our head, so to speak. And negative 8 plus 23 is 15. And so our maximum value will be equal to 15. So at this point, we find domain and range. And again, it seems like a broken record. But once again, what do you think the domain is going to be? The domain will be all real numbers. My little mic is put that back on. And so the domain is all real numbers. The range is going to be f of x less than or equal to 15 because it's a maximum point and the values are decreasing. When a is negative, the values decrease. When a is positive, the values increase. That's something you want to put down in your notebooks and learn and memorize. Very useful. So we're done with number 15. And looks like that's it. We're done with section 4.1, graphing quadratic functions. Looked like we had a good time. Hope everyone learned. And again, until we meet again, the NOLA Mathman has saved the day for your math problems, and I will see you again soon. God bless. As they say in the streets, deuces.